This conference will now be recorded.
Okay, so today in day 9, we'll be starting with the dynamic SQL, which are execute and execute immediate statements, and arrays. Now, how do we use arrays in tables and how do we fill the data in arrays? What is the use of arrays? Okay, and in the next session, we'll be covering just introduction of SAP HANA Modeling. Today, I will not give any practical examples. Tomorrow, I will show how to create attribute view, analytical view, and calculation view. Okay, so I try to close by tomorrow HANA modeling, or else I will take extra 1 hour to finish by this week. So this week I'm targeting to complete SAP HANA modeling. From next week we can start on ABAP and HANA. Okay. So today's session, what is dynamic SQL? And we'll see some examples and also arrays, and we'll see introduction. So what is a dynamic SQL? So dynamic SQL allows you to construct SQL statements during runtime. What does it mean? So far we are writing SQL statements manually, like SQL, like if you want to do a select on a particular table or if you want to do a join. So we are using, you are manually writing, right? Suppose in real time, if you want to have a SQL query dynamically generated, this is not preferred in real time, but there will be situation you may have to write, use this dynamic SQL. Okay. It can be only used in within a procedure, so you cannot use anywhere in table functions or where. So using the below constructed dynamic SQL statements in a procedure. So using the following statements, we can use create dynamic SQL. So I think we have seen apply filter in one of the examples when we are explaining about table functions, right? So can anybody tell me what is apply filter? We have already covered this one. Any idea?
Actually, apply filter is working like a select statement with the where condition. It contains uh, means two arguments where first we can take as a table where we want to take our output, and second is a where condition, like that
Yes.
we can yeah.
So apply filter is a function kind of a thing where it will expect two parameters, which is a table name and a where condition. So it will generate a dynamic query on that particular table with that where condition. So we have seen that already. So similarly, we have execute and execute immediate, where you can construct SQL statements dynamically and you can execute them. So what is EXEC? So execute. It cannot return a result set. Okay, it will just execute that query, but it will not return any result. Whereas execute immediate, it can return a result set. Okay, so we'll see about these, and we'll slowly start with arrays also. Okay, we'll start with the examples in dynamic SQL now. So this is about the theoretical part. So dynamic SQL, first we'll see, I mean, with the example of execute. For that, I will take a very simple example. So first I will create a table. Let me follow the naming standards, or I mean, recommended way of writing the query SQL statements. ID int. So I'll insert some record into this, and we'll play around with this table. So these three will be get executed and we'll have some records. And I'll create a procedure and I will try to execute a query on top of this table dynamically. So loading. Let me execute one by one. Having some problem. Let me connect to the system again. Okay, so my table has been created. I will insert these three records. So I'll create a procedure. Get movie data. So what I will do is to this particular procedure, I will pass some columns that I want to retrieve. Okay, so you can dynamically access these columns, whatever the columns that you want from this particular table. So how do we do? So using execute exeq and select. This is a string I will form. I'll concatenate the column values. Column 1, from movies. Okay, so usually if you want to select the two columns, how do we do? Select column 1, column 2 from movies, right? This is how you usually write a query. What I'm doing here, since column 1, column 2 are not fixed, we pass during runtime. Okay, while executing this procedure only, we'll pass those values. We don't know what are the columns user want to retrieve. So we have to replace column 1, column 2 with the values which are passed by the user. So we need to generate this select query and just concatenating. So we'll form a string with this select query. Okay, in this string we'll replace the column 1 with the values which are passed by the users. Okay, so we are constructing this as a string, and this string we will execute with the statement exec execute statement. Okay, so as I mentioned earlier, execute statement will not return anything. Okay, so if you go back to our slide, so execute cannot return a result set. Okay, it will just execute the statement, we will not know the result. So we will not be able to see the result at that. Okay, so let me execute this procedure. Wait. Now I'll show if this will give me a result or not, just for our testing. Call get movie data. So I'll pass these two. I want ID and name from this particular table. Okay, if I execute this, wait, there is one syntax error. Get movie data, and we are passing some parameters. I forgot the space here, that's the problem. So usually we'll give space right after select, so there is no space here, and also I'll give the space here also. Now let me call this again. Still it is giving me the same select ID. Procedure is already created, even though if I activate it will say cannot create duplicate names. So we have to create with a new procedure. I mean, I will create a new one here. Okay, fate. Now I will execute this again. Still it is, I have to call this one, right, data one, and I will do a fate. So if you see the statement successfully executed, so this query is been executed, but we're not getting the resultant set. So that's the use of execute. We will not get the resultant set. So if you use execute this one using execute immediate, you will get the resultant set back. So I will create one more procedure, get movie data 2. Here I will write like this. Okay, so execute immediate will actually return me the values. Just for the information, I'm keeping it here. So let me execute this one also, and we'll see if it will give the resultant set or not. I have to give like this, execute immediate F8. So my procedure has been created. Now I'll call this procedure. With this time I'll pass ID and director. So once I execute this, so I'll obviously get the resultant set back when we use execute immediate. Okay, that's the difference between execute and execute immediate. Okay, so we can also have where conditions also dynamically generated. Right now we're doing the selection. So what I will do is, okay, so the question is, where do we use execute and execute immediate together? So if there is a situation, suppose if you remember in our ABAP, we have a background jobs. You remember, like we actually just execute them. We don't want to show the result as soon as they are executed, right? Okay. So what it will do, suppose if you want to update some records, okay, background jobs. Are you aware of background jobs in ABAP? Yeah. So if anybody wants to have a, suppose one admin came for you and he wants to do something on a particular time frame. So he wants to update some 10 records. Okay. So execute immediate when you construct it dynamically. Okay. Suppose you want to, similarly, if you want to just not, this is just for a retrieval. If you want to update some records also, you can also do like, you can also construct insert statement, right? Insert into, okay, table name, okay, values, okay. Update insert statements actually will perform the updation. It will not return any resultant set, right? In that case, you can use. Do you want to update or delete any records? Okay, because we do not require any resultant set back. So whereas execute immediate, most of the cases when you're doing selects on a particular tables, you can use them, because when you do a select, we actually need to show what are the resultant set that we have executed. So execute alone you can use for updation or data DML operations, because we did not require anything back, resultant set back. Whereas execute immediate, most of the cases we can use for queries, because when you do a query, we need to get the resultant set back. Okay. So this is actually not a recommended way. So these are having some problems called SQL injections, where no. So as usually, so the other question is anything reference to asset property. No, Shankar. So these are actually execute immediate, no wait period. Execute immediate in the sense, as soon as we execute that particular call that procedure, it will immediately execute, yes, without any time period. Select also, execute also will do execute the statement, but will not get the resultant back. So when you want to do updates or deletes and DML operations, so we don't require data return. So before you get too many doubts, let me clarify one thing. These are all not recommended ways, okay, to write SQL queries dynamically like this. This is in any case, if there is a requirement that you want to perform a SQL statement dynamically, this is one of the options that we can go, but this is not a recommended way, because if you write like this, these are pretty much what you call vulnerable to hacking. Okay, people can send any values here. Okay, column names for people who are not having access, so they can do, I mean, pretty much vulnerable to hacking, so, which are called SQL injections in a database context. Okay, this is just for our knowledge. If in case if you have to write a dynamic SQL which will execute immediate or execute like this, we can use these concepts. Real time, I would say 90% of the cases you will not write this. Okay, so we just selected the columns, so we haven't formed a dynamic where clause here. So now let's see how to do a where class. So first I will do a simple one with where condition. So one more thing, we are, as an ABAP and HANA consultant, we are actually learning more things on SAP HANA sites. Even people who are working on HANA will not aware. So, okay. So most of the cases in other institute, they will not go this much deep. They just cover the basics of procedure and table functions. They will not cover like triggers, the DB views and all. Okay. Now I'll create another one 3. What I will do, I will pass one more condition for where condition. Right now I will not take, I will directly form here itself. Or what I will say, where id equal to 10. So let me call. So let me execute this first. Here I'm not dynamically passing the where condition. Within the execute immediate call itself, I am forming the string with where condition. So in the next example, we'll see how to replace with where condition dynamically. Problem with the connection again. Now I will call this get movie data 3. Okay, here I will pass column name, and so it has to retrieve the only record which is having value as 10. Okay, so I got the only that particular row. Now if you want to pass the same thing as dynamically, we can do it. With dynamic where. So here I will import another parameter called condition, which can be of length 200. So we can send as much as you want. So what I will do, from movies up to where it is same, but from here we will pass that condition here, whatever the condition that user has entered. Simple. So when we pass during runtime, this where clause will be replaced with whatever the conditions that we have passed. If it. Now I will call this time I'll pass id director. Here I will pass where id equal to 10. Same thing I am passing here. Okay, I'm passing the where condition here itself. We can also pass and name equal to like this also. Okay, I'm just simply passing normal just one condition. If I execute this, it has to give me the particular row. So just like how we have got the result from this particular procedure, we got the same result. So in this way we can also generate a where condition dynamically. It's a very small topic. Okay, this is how you can use execute and execute immediate within a procedure. Okay, keep in mind that we can use only this within a procedure. Okay, the next topic. So apply filter we have seen, right? So what we will do, this is also one of the way to generate query dynamically on a single table. Okay, so next topic is arrays in SQL. So what is an array exactly? So array is a indexed collection of a single data type. Okay, so what is a collection of single data type? So if you want to store a particular set of values which are belongs to same data type, suppose I have certain 10 integers and I would like to store in a single array. So all the numbers are data type of integer. Okay, so this is the collection of same data type, so I can store them in a single array. So in the following session, we'll explore varying ways of define and use arrays in a SQL script. So example, so if you want to create an array, simply you say declare a1, this is array name. What is the data type of this array? So what kind of a collection that you want? So if you declare it as vark, every value that you insert into this particular array should be vark 10. Okay. So in order to make this an array, you have to keep this keyword called array. Okay. So there are two different things that we need to focus on in arrays. There are some concepts. One is array underscore aggregate function. So what this function will do is aggregates a set of values into an array. What is the set of value? Suppose suppose there is one column in my table, so I want to retrieve all the records and I want to do some processing on that particular column. I want to go through each row of that particular column. I can convert that into an array and I can process each value. If you remember our example, like employee payroll, so in our procedure, where you are actually, uh, what you call, by passing the index to that particular table, you are accessing particular column value. So here you can convert that into an array. You can also access in this way also by passing index. We'll see example on this one also. And unnest is something which will actually do the reverse of aggregate function. Aggregate, what it will do, it will convert a column into an array, where unnest will actually converts an array of values into a column. Okay. So one more function which is called cardinality, which actually returns the size of an array. So suppose in this example, if you see, we have a declare a1 varchar array. So up to how many records it can hold each array? So up to 2 to the power of 31 records it can hold. That means approximately 21 billion records a single array can hold. Okay, this is just a fun fact. So we'll see examples on these array aggregation, unnest, and cardinality also in our example. So let me go back to our Eclipse, and here we will see, as usual, we'll start from the scratch, very basics. So we'll create a procedure just to show how to fill an array. Create procedure. The reason why I'm creating procedure every example is because in real time we'll always be working on procedures. So it is always better to write in procedure. That's the reason I'm showing everything in this way. So I will simply say procedure as begin, end. So how do we declare an array? Declare my array. You can give any name here. So what kind of data you want to hold in this array? So I want to have a string which is having 10 characters. So I need to make this an array like this. So I have an array called my array. So how do you fill this array? Simply my array 0, I will say first record. Okay. So purposefully I'm doing this. So let's see what will happen if you try to execute this array. Fit. System is a little slow. So let me execute again. So what is the error that we are getting here? So numeric or value error. So only array index starts from 1 to up to 2 to the power 31 is allowed. So what it is saying, array row will always start from 1. Okay, when I'm trying to insert a record at a 0th position, it is giving me an error because we cannot start from 0, it will always start from 1. Just to show that I have created this example. So now I will simply fill data in that array. So I have to start from here 1. Second, third record. Can anybody tell me if I execute this one, what will my array, what is the value that my array will hold if I execute this? If I try to execute this, yes. So we'll have only the fourth record. So everything will be overwritten one by one. So we have to, if you want to insert multiple records, this is where you can do into that array. So I'll do a fate. So how do I call that? So I will do a select on this. So how do I access to the particular record from an array? So I can say by mentioning the index from that particular array using select. And I do a fate. So let me make this as a dynamic one. So what I will do, I'll say it as I and say in index. Okay, which is of integer. Let me try this way. So what I will do, whatever the record that I want to access from this particular array, I will pass that value. If I say second, if I pass 2, I should get the second record. If I pass 3, I should get the fourth record. Let me execute this fate. Okay, this is actually the one that we have to pass from whatever we are passing. So we'll do a fate. So now I will try to get a specific record from this array 2. So I want to retrieve the record 1. Let me access a fate. So I will get the first record. Now I want to retrieve the second one. I will get the second record. Okay, this is how you can access array and fill an array and access the same thing. Now we'll see how to convert a set of values into an array. Okay, so we'll convert a column into an array. Okay, so right now we already have a table, right, which is having a movie data. Using array aggregate to convert column to an array. Create procedure array aggregation example as begin end. So I will declare my array varchar 10 array. So I will do a select on my table, select star from movies. So from this movies, I want to take only directors. Okay, what are the who are the directors in this particular table? So I want to have an array of values which is containing director names. So let's see how we can convert. So I have already declared a varchar 10, right? So because so here I think I have given us 30, so I will give 30 because these are the things that I want to hold. The same data type you need to give for which column you want to convert. So how do I convert? So array aggregation. From this table, I want to convert this column into an array. Simple. So in this array, now I will have all the director names which have retrieved from the particular column. Okay, so how do I do the select? So from that, so just like how we access an array, similarly we can access this. Select my array. So you can pass an index. I will say I as record from dummy. So let me execute this. Fate. So I have not given the input parameter. I'll say I integer. Okay, then I will execute this. Fate. So what did this procedure? When I call this procedure, it will retrieve the records from movies. From that movies, so when I execute the statement, my I tab will have all the records, internal table, and from that I tab, I'm extracting column director and I'm converting that into an array. Then I can access that particular column values using this particular array by passing the index. You can also keep this in for loop. Okay, if you want to retrieve all the records. Okay, we have seen this example, right? In 1 to up to how many records you want to retrieve, and you pass that index here, you can extract one by one value of that particular record. Okay, so now let me execute this. So I have already executed, and now call this array aggregation, and I will pass I think we'll get always the same value because all the values are Zach in this case for that particular director. So it doesn't matter which index you pass, it will always retrieve me that particular record. Okay, so now we'll see another example on how to use an array in a table. Okay, in a table. So usually we always have columns in a table, right? We just a column will hold a single value. So if you want to hold a number of values for a particular row, so you can have this flexibility. So now I will create a table, or I will make one of the columns as an array. Let's see how this work. Material ID, I will say integer. Let's say it as a primary key and description. Varchar, I can declare like this. Now my column will become an array for this particular row. Okay, so I'll do a fate. So when I go to the table definition, let me open the catalog, system, tables. So what is our table, which is materials? Let me open the definition. I'm just curious how this particular column description will be there. So here you can see it is saying which is of data type array data type. Okay, so which is having string. So how do we insert the records into this insertion? So usually when you try to insert values, you just specify a single value for that particular column. But when we have arrays, it is a little bit different. Values. So I'll pass the ID material description and the values that I would like to pass to this particular what you call description column. So what I will say, I have to pass this way. So I will hold description of my material in different languages. Let's say French or whatever. Okay, German. So I'm holding three different descriptions for this particular ID. Okay, in the same row. So this is how you need to fill an array. If you have a column which is having as an array, so you will pass the values like this to this particular column. Okay, so let me execute this. Now if I want to retrieve the data, let's see how the data looks. Select star from materials, fate. So this is how my data looks like. So it will hold different values in the single column. Now what I would like to do, so how do we convert this into a table, this particular description column? So we have seen array aggregation, which will convert a column into an array. But in this case, I have an array, I want to convert this into a column. Okay, so using unnest, we can do this. Using unnest function, you can do that. So I will show how to do that. So if you let me do a select on this particular column, let's see how it behaves. Select description from materials. So how this will look like? This will look like this. Okay, single column which is having multiple values. And if I want to convert this one to a table, so I can do like this. Select star from unnest materials from this table and this column DESC I would like to convert into a table. This is just an information we can give. So this will appear as a column name. Okay, clear? So right now, if you look at a result, it is having a single row with all the values. And if you want to convert that into a column, table or rows, you need to use unnest function. And which column you want to unnest, you have to specify like this. Okay, this info will actually become as a description for that. So when I do F8, you see how this is converted. So if I execute both of these, F8, you can see the difference. Here if you see everything in a single line, once I do the unnest, it will convert the same into a table. Okay, so this is how unnest works. So if you want to convert an array values into a columns, I personally did not use so far, but just keep this in your list. So whenever there is a requirement, you can use that. And we'll see about cardinality also. This is about using unnest to convert column, sorry, to convert array into a table. Now the next example is cardinality. This is a very simple example. So whenever there is a situation that you want to know the number of records that you want to retrieve from that array, you can do this. You just simply returns the number of records which are there in that particular array. So what I'm saying here, cardinality of this particular column, because since this column is an array, so it will treat as an array from this particular table and it will retrieve me the records. So when do we need to find the cardinality? Suppose when you want to loop through this particular array, usually we don't know how many records we have to loop, right? So for I in 1 to cardinality of that particular array, you can loop if you want to loop. So to find out the number of records, so it will loop up to how many records which are there in this particular array. So in this case, cardinality will become handy. So this is about arrays and unnest aggregation and cardinality. So this is how we can use arrays. And so any doubts so far in these examples?
No, so no, and many of times we need to use these within procedures. For example, you told execute and immediate execute. Do we need to
Yes.
use within procedures all the above examples? Is that the case? Means
You mean execute immediate or arrays or
for both, I'm asking execute and immediate execute. We need to use in within procedures,
yes,
right?
execute immediate we have to use in procedure only. Arrays we can use anywhere in table functions procedure I can use. Okay, so this is about the first session that we have seen here using unnest aggregation and dynamic SQL. So I'll take a 5 minutes break. I will cover up this HANA model introduction, just 15 minutes or 20 minutes I will take. So tomorrow we'll see clearly and with real-time examples in SAP HANA modeling. Okay, let's take a 5 minutes break.
This conference will now be recorded.
Okay, so in the previous session we have covered the about topics which are dynamic SQL and arrays. So in this session, I will just cover the theoretical part of SAP HANA modeling, and we'll have a look at what is attribute view, analytical view, and the calculation view also. So we'll understand when do we create attribute views, analytical views, or calculation views, and we'll dig little deeper about attribute views and analytical views. We'll know some facts. Okay. So basically, when you, I mean, if you go to our go back to our traditional SC11, right? We have SC11 where we can create views. If you go back to our ABAP, right, where we can create views like we'll specify tables, join conditions, and all. Okay, so similar thing with additional functionalities, SAP HANA has also concept called modeling. So these are very enhanced way of creating views. So in ABAP we have very much limitations, right? We cannot use. There are different things that we cannot use. But in SAP HANA modeling, we have a flexible tool where we can use a graphical editor. Okay, you do not have to worry. I mean, like mention the table names. Okay, you like join conditions and all. It's like a drag and drop thing. So for developer flexibility is there. We can quickly finish the development in a minimal amount of time. So most of the cases, the modeling will be used for reporting purposes. Okay, if they want to get a sales order and item data for a particular given date, they can join those two tables in a graphical editor, and they can simply keep what are the fields that they want. So everything will happen dynamic. I mean, in a graphical editor. So we'll not be writing select queries. This is all when you're linking the tables and connecting the nodes and everything. Automatically, a view will be created on top of those particular what you call attribute view or analytical views. Okay, with the select query will be dynamically generated based on the views that we are creating in the graphical editor. Okay, so let me show you just an overview. So if you want to create, so there are one more thing, we can also switch to SAP HANA modeler perspective. So far we are in SAP HANA development perspective. There is one more option called SAP HANA modeler. You can switch to that and you can start creating your models itself. Okay, but I always prefer SAP HANA modeling only. We can also create within SAP HANA modeling, SAP HANA development perspective also. So I will show the graphical editor how it looks. So this is how the graph editor looks like. So we do not have to worry about writing select queries and all. So what we will do, we just simply add those tables that you want to join or anything. So this is how where we create attribute views or calculation views or anything. Okay, so we'll going forward, we will see. And for now, do not worry about how do we create and all. But this is the editor that we use for creating the graphic. This is the graphical editor for creating everything. So as soon as we create or activate, there will be a column generated. Column view will be generated on top of this under this schema, under sysbig underscore schema. Okay, this is pretty important. Some interview questions also. As soon as you create, activate attribute or analytical view or calculation view, anything, there will be a column view will be generated under this schema. Why this schema? Under this schema will be this a column view will be created with the same name under this schema. So this schema, this view can be given to a BA consultant, okay, can be exposed to an ABAP consultant. So whenever you want to export this particular attribute view, what you will do is you will give this column view. You will not give this attribute view, this graphical editor, whatever it is there. Okay. So this column view name will be provided to the BA developer. Whoever wants to consume this particular attribute view will be calling this way. So schema dot the path, I mean where the what you call view has been created. Okay. So for outer world, this is how they will access using this column view name. They cannot directly call like this. Okay. Now coming back to views, modeling views. So the main idea of any SAP HANA modeling is to generate reports. Okay. So why to generate reports? As part of this, we have different types of views available. Using these views, we can fetch data and implement the business logic on top of HANA database to create reports for effective decision making. So in real time for customers, in order to make a decision for the customer, they have to see the reports, generate reports, right? Just like how we do in our ABAP. So on top of HANA DB, we can create these views for effective decision making for the customer. So as I said, these views can be exposed to different reporting tools such as BO, business objects, Lumira also, and we can also expose this view to Excel. Okay, there are different ways that end user can consume. But as a developer, what we have to do is we just need to create an attribute view, and we have to give the person who want to consume this object name. Okay, that is our job. It doesn't matter how they'll consume or everything. That is not our job. All we have to do is we have to tell the BA consultant or the respective person who wants to consume this, we have to give this object name. So there are different types of views. We have attribute views, analytical views, and calculation views. So before I actually discuss about this attribute views and analytical views, there is one thing that we have to keep in mind. Attribute views and analytical views are actually deprecated. 80 to 90% of the projects are not using attribute views and analytical views. So from which version it has been deprecated? I will say SAP HANA 1.0 SP11. Okay, since this version, attribute views and analytical views are deprecated. So if you are assigned to a project who they are working on this version, you may need to work on this attribute view analytical views. So that's the reason I will show some examples on attribute view and analytical views also. So in case if you have to work on older versions. So right now, 90% of the cases we'll always go with calculation views. But before that, we know about calculation views. We have to understand these two views because these are the two views we'll be also using in calculation view also. Okay. So what is an attribute view? So attribute views are to model data such as VBAK, MARA, MARC. So we can join multiple database tables. So this view runs on a join engine, which is a part of a SAP HANA architecture. Okay. So what is an attribute view? If you look at these tables, you see VBAK, MARA, MARC tables. These are all hold attribute information, right? And they will not hold. Suppose if you take material, we don't require we do not want extra information what do you call? We do not see how much revenue is generated. In Mara table, we will not get that information, which are actually called measures. Measures are something which is quantifiable entity. So what is quantifiable entity? Suppose there is a sales order. In the sales order, I have made $1,000 per month for all the 100 sales orders. So we are actually seeing some value, some integer value or decimal value, whatever it is, which is called a measure. So, so we'll know that this much amount is generated. But in attribute view, we'll not have these values. We just have a normal description type of views. So if you take MARC, MAKT, so if you join MA Mara and MAKT, we'll have materials and material description. There is no extra information on the net value, profits, and all these are all things will not be there in attribute view. Simply put, we'll not do have any calculation values which are such as integer type, numeric. Okay, so attribute view it just holds the normal things. Okay, like descriptions, sales order data and everything. We will not have integer values which will show actual amount, revenue. These are all things will not be there. Okay, when it comes to analytical view, it is a combination of transactional data and master data. So attribute view will only happen on master data. Okay, so I hope you guys are aware, right, what is master data and transactional data. Okay, so attribute views will always be performed on attribute master data, and analytical views will be the combination of transactional data and the master data. So as we already know that attribute views are created on top of master data tables. Okay, so to clearly understand analytical view, so I have two examples here. Okay, if you look at user data, let's imagine I would like to develop an application, okay, which will track the amount spent by the user each day. Okay, let's say he just want to track how much amount he is spending on a day to day. So we'll have to come up with two tables. One is master data, which is the users which are using that app, which will not be frequently changed, right? So that's a master data where we'll have user IDs 10, 20, username Christopher and city. And if you want to track how much amount that is spending by this customer daily, okay, if you take the user ID 10, if you look at in the right table, we have customer ID 10 where we are capturing the transactional data. So this is a transaction table, transactional data. Okay, for this user, for this date, he has spent 200 euros, 1 pounds or euros. So category will be shopping. So this is holding a transactional data. So in order to, so imagine we're developing an application like this. Okay, so if if you look at these two tables, if I have to make a comment on this day, so somebody asked me how much Christopher has spent. So what I can say is I had to look at the user ID of Christopher in master data table, right? First. So based on that user ID, which is a master table, then I have to look at the transactional data, how much he has spent. I will go through the transactional data and I will see on a date, uh, New Year evening, so he has spent 300 euros on shopping and food. Okay, if somebody asks you a question, how much Christopher has spent. So you will look at the master data to get the user ID, and from that user ID, you will look at the transactional data to check how much amount he actually spent. You see, this justifies our definition. See, in general, this is view is combination of transactional data and master data. Okay, that's why I look at the master table for the specific information. From master table, I will go to transactional data to get quantifiable information. Got it? Here the field which contains numbers which are called tangible analysis, such as amount spent, revenue, and product sold, which are called measures in SAP HANA Modeling. Okay, and the other things which are called attributes. The columns which hold actual values we are called as measures for tangible because they are we can analyze. These are called tangible analysis, such as amount spent, revenue, and product sold. Okay, so this is about analytical view and attribute view. Now we'll go a little deeper. Okay, So you must be asking why this attribute view and analytical views are deprecated. The reason is, if you remember our HANA architecture, like we have a different types of engines to take care specific task. Okay, so we'll have a, this is part of HANA architecture. We'll have a calculation engine, OLAP engine, and join engine. So as you can see in the diagram, the analytical views run on OLAP engine. Okay, which will, this is the part in the architecture will take care of executing this analytical view. Okay, whereas calculation views run on calculation engine, and attributes view will run on join engine, because attribute view is nothing but a simple join on different tables. Okay, and whenever you want to show or retrieve, calculate some values, this will be, analytical view will come into the picture and it will run on OLAP engine during runtime. So in earlier developments, these views are consumed within one and another. Okay, due to this, there is a lot of data transfer among all of these engine. Okay, because calculation view can combine both attribute views and analytical views also. In this case, calculation view should be executed on calculation engine. Overlap engine will execute, join engine will execute, and there will be a data transfer between these three engines. Okay. So to simplify this, SAP has come up with an idea by avoiding this analytical view and attribute view. So right now we have only calculation engine, which can also do what these views can do with different options. What does it mean? So you remove this overlap engine and join engine. So now we will have a calculation engine which are integrated into one engine. Now, if there is a situation, then how do I do analytical views and attribute? Because I have a calculation view only now. So using calculation view, we have an option called, two different options called dimension and cube. Okay, let me go back to our editor. So for a calculation view, if I have to create a calculation view, there is a what you call option called data category, which is cube and dimension. If you see, if you set a data category as cube, the default node is aggregation. You can change the default node to, okay, forget about this, not required for now. So cube and dimension. So dimension is nothing but an attribute view. Okay, cube is nothing but a analytical view. Okay, this is how you can create attribute view, analytical view within the same calculation view, so that we will not have different engines to run on this. So calculation engine will take care of all this. Okay, so cube is for analytical views and dimension is for attribute view. If you are going to create attribute view, like if you want to only the description data like material data, sales order data, if you want to do the join only on master tables, you'll go with dimension. And if you want to combine master table and transaction data, you will use cube. Okay, as simple as that. So this is a reason they have avoided all these things in so that we do not have to execute everything in multiple engines. Okay, now calculation view, as I said earlier, we'll have dimensions for attribute kind of use. Like if you want to create attribute use, we'll choose data category as dimension, whereas for transactional analysis, we'll create cube, data category as cube. So by using calculation view, we can create meaningful data model which can be consumed for reporting purposes. So calculation views can be created using graphical editor, using SQL script. We can also create using SQL script also. Okay, so calculation views, we can integrate a table function also by, so whenever you execute a calculation view, if you want to execute a table function, some logic, if you want to borrow from a table function, we can also do that. So If the requirement is quite complex, we can use SQL script instead of graphical editor. Suppose you are using too many tables and you want to write a simple query on those tables instead of having wasting your time on graphical editor. If it can be done within a single query or something, we can keep that in a table function, and that table function can be consumed in a calculation view. So graphical editor is a developer friendly, and we have already seen. So when we are creating attribute and analytical views, we are not written a single piece of code here. Okay, everything will be a drag and drop. You do not have to worry about underlying logic while using the graphical editor. Okay, so calculation view can also be created with a table function also. Okay, so these are all things we'll see going forward. So tomorrow I will create attribute view, analytical view. So it's better to learn these two also. And calculation will be when you want to create a calculation view, it will be a piece of cake for you if you know these two. Okay, even though these are deprecated. So for our knowledge to create calculation view, it will be very helpful. So remember, if you get a chance to work on HANA modeling, so it's strongly recommended not to use these two views. Instead, you have to go for calculation view with by choosing the data category that you're going to perform based on the tables that you use. Okay, any doubts so far?
No, I think whatever you told, apply underscore filter and input parameters, those we can also use graphically in calculation view, correct?
Yes,
Okay.
we can have different things in here. We can have calculated columns, restricted columns. There are a lot of things. So it's a very flexible way of creating views. Okay, so this is for today. Tomorrow we'll actually start the practical example. I will just give you overview again tomorrow, and we'll start creating attribute views and analytical views in first session. And the final session, we'll create a calculation view with all the options that we want. If it takes time, we'll also take a 1 hour class during this week, coming week. So this week we'll finish this SAP HANA modeling, and we can go to ABAP and HANA from next week. We'll start with the will new syntaxes, and then we'll start reporting on HANA. Okay.
One question, not from this topic. Actually, it seems that HANA modeler, our scope of work seems to be less in when we compare with ABAP on HANA, because here only we are doing graphical modeling,
Mhm.
and and ABAP we have more work, means scope of work is more, and here in HANA modeling scope of work seems to be less. Is that the case or how it is?
So this is actually depends. Suppose most of the cases, ABAP developer, most of the cases will not get the chance to directly create views on SAP HANA modeling. But it is always to have a knowledge on this. So they will hire SAP HANA modeling guys to generate these views, and those guys will give us the views to consume in our ABAP. This view they will give. But if you know this, if the person or your team lead, whoever, you can tell them that I can also create these things, and you can create this directly here with very much flexibility, and you can just consume this with a single query from ABAP.
Okay. And one question, normally consume word is used. Consume, wherever in interview question I saw how to consume CDS views, how to consume this. Consume means whatever we are creating, and when we have to use in our coding, that is called consume.
Consumption, yes.
Okay, okay, consumption. Okay, fine.
So people who are on working on BW, if they want to get some data from our SAP HANA, so they can create a view on top of those tables and they can get the data by using this view.
Okay, fine.
Yeah. And just a second, I have another the two questions from Mansi. Why we have checkbox of deprecate here? Mansi, I'm not aware of this, but I will check this and deprecate this checkbox. Okay. Okay, this is for today, and we'll see you tomorrow. Okay. Have a nice day, guys. Bye.